Limits. Finding limits. Using tables and algebraically. Algebraically is the easiest way to do it, especially if it's a simple function that you're plugging into, and you just plug it in and you get your answer. If it's not a simple function, there's other stuff we have to do, which we'll talk about hopefully tomorrow if we get through these. So a limit, which is represented by LIM, abbreviation of limit, of some function. So f of x is just a function. Whatever that function is, it gives it to you. Or it'll give you the graph of the function. As x approaches c, so you're looking at your graph or your function at a specific x value. And this c value will also be given to you. That's always going to equal a y value every single time. So limits, you're looking at an x, an input, and you're getting out the y value, which is an output. Plug in, get it out. It's kind of just like plugging in and then getting your answer. But there's some extra steps with limits when they're indeterminate or unsolvable. So if you're good with plugging in and substituting, then you're good to go. Given the function and the value that the x is approaching, you determine the y value. Always the y value. It's the y value that you're looking for. So that would be the y-axis, the one that's going up and down, the vertical axis. So if you're looking at a graph, you're going to look at the y value that it's approaching. If you're looking at the actual function, you're plugging in and getting your output, which is the y value. Okay, so you plug in, get out the y. If you're looking at the graph, you're looking at the y. Always the y. Okay. And you always look from the left and the right side. So if you watch the movie Mean Girls, which I'm assuming most of you girls have, not sure about the boys, but when Lindsay Lohan says the limit does not exist, that does happen. And when that does happen is when the left and the right side are not meeting at the same point. So that's when it does not exist, is when your functions go on here and here in two opposite spots. So that's when it doesn't exist. There's using the table to determine the limit, and the easiest way to do that is use your calculator to your advantage. So you plug the function into y equals and pick points on the left side and the right side, it's always left side and the right side, to figure out what those are approaching. So if I wanted to find the limit of 5x squared as x approaches 3, now I could just plug in and figure out what it is, but you need to understand where it's actually coming from and what's happening on the left side and the right side to actually understand what's going on with limits. So if I want to figure out what the limit is as x approaches 3 of the function 5x squared, I want to figure out values that are close to 3 on the left side and the right side. So I'm approaching 3. That's what I'm approaching. I'm getting closer and closer on the left and the right. That's where they're both pointing towards 3. I want to figure out values that are really, 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 really close to 3 on the left side and the right side. So if I was looking on the left side, what's a number that's really, really close to 3 that's below it? Because the left side would be below. Really close. 2.999, can we say? And then make it a little bigger, 2.99, and then 2.9. Because you want to see exactly where it's going, so you want to use smaller decimals. So if I went on the opposite side, what's something a little bit larger than 3? 3.001. And then a little bit bigger than that would be 3.01 and 3.1. And the easiest way to do that is always increase the decimal place or decrease the decimal place. So start with 3 decimals, and then go to 2, and then go to 1. So the easiest way to evaluate this on your calculator, and I suggest you grab a calculator if you don't have one. You want to plug in the actual function that's given to you. So you're given the function of 5x squared. That's what's given. So if you plug in 5x squared in your y equals, and you want to evaluate it at all these points without typing it in 5,000 times, because that gets obnoxious and annoying and a pain in the butt, you go to there. Go to the button that's called vars, that means variables. Go over to y variables. It is a function because you typed in a function into y equals, yes. Go to vars, which means variables. Go over to y vars, which means the y variables, and you want function. And that pops up any function that you would type in the y equals button. So y1 just means the function I just typed into y1. So I hit enter. Since I typed that into y1, I could tell it to evaluate at 2.999. Ta-da! Plug it in, hit enter. I get my answer. So that's 44.97. Whoops. And you can round further if it ends up being some crazy decimal. But as long as you can see approximately where it's going, then you're okay. If I go to that same option and just delete one of my 9s, so I'd have 2.99. So remember, you can, on the new calculators, you can hit up and hit enter and it'll bring it down, or you can hit second enter, which will bring the last entry that you typed in. Hit enter again, and I get 44, oh my gosh, 0.70. And if I do it again, delete another 9, I get 42.05. So I'd want to do the same thing for the right side of that value. So 3.001, 3.01, and 3.1. If I type in 3.001, I get 45.03. So if I finish my table, which at this point, you know what it's approaching on the left side and the right side, what these two values are getting closer to? It's getting closer to 45. Sometimes they're pretty whole numbers, sometimes they're ugly fractions, and you have to remember, like, 0.33333 is 1/3. And if you don't, then you start typing in numbers in your calculator and figure out what the fraction is. So if I were to finish it, to make my table complete, oh, shoot. You're not what I wanted, but that's okay. I get 45.30. Oh, stop hitting the wrong buttons. I get 48.05. So these last two, I mean, depending on how large you make your table, should always be the furthest away, and you're getting slowly closer to some value that's in between these ones that are right next to it. Okay? So if it's not something that you could determine, then you need to make your decimal even smaller. So it'd be 2.9999, so 4 nines, if you can't determine what it is. Okay? Does that make sense? So now if I have the limit of x squared minus 4 divided by x minus 2 as x approaches 2. So I'm approaching 2, so x approaches 2, of that original function, x squared minus 4 divided by x minus 2. So the last one I actually could have typed in 3 and got 45. This one you cannot. Can anybody tell me why you can't type in 2 and get an answer? What would happen if I typed in 2? I'd get 0 in my denominator, and can you divide by 0? No. There's a way to do it algebraically. We'll talk about that in a little bit. So, if I were to type that in, I would have, what's a value that's close to 2 is what I'm approaching. 1.999, 1.99, and 1.9. And what's something larger than 2 on the right side? 2.001, 2.01, and 2.1. Alright, I'm going to let you guys do that. So what you guys get for number 2 as x approaches 2? 4. What you get if you're done with it for number 3 as x approaches 0? 1. Dun 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 dun. They're not always negative on that side. That happens sometimes. Usually around 1. Or, around 0, that happens. Alright, so, evaluating limits algebraically. If you are able to plug in and get your answer, you're good to go. If you're not able to plug in and you get 0 on the bottom, like number 2 that we just talked about, then you're in trouble. But if you're able to plug in and get an answer, you're done. Because you're plugging in... Sorry. You're plugging in an x and getting out a y. So, if I were to plug in negative 2 into that function at all, am I going to get 0 in my denominator? No, I don't have a denominator, so I can't get 0 in my denominator, so I'm going to get an answer if I plug in negative 2. So, if I plug in negative 2, the only thing you have to be careful about is when you're plugging in negative, do you actually put parentheses around it, especially if you're squaring something or cubing something or whatever. So it's just like evaluating the function. I'm plugging in negative 2 into my x, so I'd have negative 2 squared plus 1, which would give me what? 4 plus 1 would give me 5. Good job. So if I went to number 2, I do have a denominator, but if I plug in 3, do I get 0 in my denominator? No, there's no way I can get 0 in my denominator if I'm plugging in 3. So I just plug in 3 into the x, because that's what it's approaching. So 3 to the third minus 12 divided by 3. So all you're doing is replacing the x with the actual value that it is. So 3 to the third, 27 minus 12 divided by 3, 15 divided by 3 equals 5. I'm fine if you plug in here and give me the answer. All this can be done in the calculator, but if you plug in and then get the wrong answer, you're going to lose points because you plugged it in wrong somewhere. Okay? So you need to show me actually plugging in without simplifying anything, and then the answer. The in-between stuff, simplifying individually, you don't have to do. If you want to, go for it, but you don't have to. So if I plug in negative 4, I don't have a denominator, so I don't have to worry about if I get 0 in my denominator. So if I plug in negative 4 squared plus 5 times negative 4 plus 8, what's wrong with that? You need parentheses around something that you're plugging in, especially if it's a negative. I think you should put them around them all the time, so you're careful, but So if I were to plug that in my calculator or actually go through and do the math behind it, I would get 16 minus 20 plus 8, which would give me what? Ta-da! If I plug in negative 2, I do have a denominator. Will I get 0? No, there's no possible way to get 0 in my denominator because I only have x in there. So if I plug in negative 2 into my x's, I would have negative 2 plus negative 2 squared divided by, what do I do if I have a negative x? I leave it out there, right? Negative times a negative 2 would change to a positive, correct? So I got negative 2 plus 4 divided by negative of negative 2 would become a positive 2. So I'd get a whole whopping 2 over 2, which would give me 1. Dun, 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 dun. Is everybody okay with these? Questions on those? Five, 6, and 7 are the same idea. You just have an extra step. You have a square root, a more complex fraction, and then another square root. So if I were to plug those in, I would get square root of 2 times negative 2 squared plus 1, which would give me 2 times 4 plus 1, which gives me what? Square root of 9, which gives me 3. Would I put a plus or a minus in front of it? No, why? I don't put a plus or minus in front of it because I'm not adding the square root to cancel out a square. The square root's already there, so I'm not adding something to get rid of it. So, try to finish 6 and 7, because the bell's about to ring. And we'll talk about the last part tomorrow. And if you're not here tomorrow, then I will send you the video. Okay?